Hello folks, welcome back to Learning with Lunchy. Today we're going to take a look at our 6th grade's latest topics in my school, in my class. We are doing the rock cycle, which contains all 3 types of rocks, starting with igneous rocks, going to sedimentary rocks, and metamorphic rocks. All of them form a circle and they all interconnect, hence the rock cycle. So I don't have an actual volcano to show you, or the erosion of the earth, or the crushing powers of an earthquake to show you how to make these rocks at the moment, but I do have a large sample of these rocks from all my years of travel, as well as plenty of digs that I've been to throughout my career as a paleontologist and throughout my adventures around the world. To start off today's lesson, we're going to go over what are some igneous rocks. So there are 2 types of igneous rocks. They're intrusive and extrusive. Intrusive meaning inside the crust of the earth, and extrusive as in exit, as in exploding or out, creating out of the earth. And our 2 rocks that sample extrusive are these 2 right here. So we can see these both rocks are called basalt. They're both slightly different. Both of them cooled really quickly from a lava flowing on the surface of the earth. These are from Hawaii. So if you've ever been to Hawaii, you may have seen stuff like this before. There's a beach, quite a few beaches in Hawaii that are black sand beaches. They're actually made from basalt like this, being broken down as it crushes itself and turns into sand pebbles. This one's extremely light. It cooled really quickly. You can see where air bubbles were trying to get out and pop out. This is dried up lava. And this one also cooled fairly quickly. You can see the air bubble holes. And if you look real closely, you could kind of see some pretty cool crystals in there that are shiny. Those are unique little minerals that are found in a lot of igneous rocks. So igneous rocks are made of crystals rather than sediments. Crystals are literally growing, almost like humans and other animals as they grow. So they start off small, and then if you give them enough time to cool, they actually grow into big crystals. You can actually get a bunch of different cool, huge quartz crystals and things like that. Which leads me to the next one. This is a really cool piece. Someone got it for me a long time ago. But this is a slice of a geode, which is an igneous rock. And so this right here is quartz. And over time, the rock actually was a sphere like this. Can you imagine it just had a slice taken out of it, like a piece of bread? And these crystals grew in the middle. Some of them might be calcite, because that's what geodes tend to be, but these inner layers are more or less quartz, especially this edge, around the edge. Quartz is a very common mineral that is found in igneous rocks. Alright, our next rocks are sedimentary rocks, and they're my favorite because it contain cool things like this, and this, and this, and they contain fossils. So sedimentary rocks is a rock, just like one of these, that has been broken down into small pieces of sediment, and then over time compacted together to make a new layer of rock. All the fossils in the world come from sedimentary rocks. And so let's take a look at some cool samples I have right here. And so here is an ancient snail in as you can see, sedimentary rock on the back. This snail is roughly 500 million years old. We have a ammonite, which is very close and similar to the modern day nautilus. You can see the little chambers. This is from the Cretaceous, so it's about 70 million years old, roughly the same age as the dinosaurs. This is another sample, and you can see there's the sediments in here. You can see little pebbles and sand particles concrete together. You can also see the main object. This is a big tooth. This is a tooth from a mosasaur. This is roughly 100 million years old and still same time as the dinosaurs. These guys lived in the ocean though. So very cool. These are a little more modern. This one in particular is a spine or a backbone of a whale. Imagine this is the top of your back, and this is the little wings that come out. This one has a broken, and you would have another one of these stacked up, and then the ribs would come out on the bottom like that. This whale is found from Florida. This is about a 2 to 3 million year old whale fossil. And this is the same age and from the same quarry in Florida as well. And you can see it is another whale vertebra. You can see the processes coming out. A little too small. This one might have been a rib that came out like that. But if you look closely, there's some sedimentary rock right there. Little siltstone. And you can see little tiny shells of snails and clams and stuff still stuck to the side of this bone as it was compacted over time. So those are the sedimentary rocks. Some of the big, more well-known sedimentary rocks are sandstones and mudstones. All of our natural fossil fuels come from sedimentary rocks. So oil, coal, natural gas, they all are from sedimentary rocks in some formal way. Then these are the next group of rocks, which is this set of rocks right here. These are metamorphic rocks. They look similar to sedimentary rocks, and that's because they can actually be from a sedimentary rock or from an igneous rock. That's all part of the cycle. It all connects. So this one right here is called a blue schist. And you can see kind of layers in it. It's very pretty. And you imagine this rock sitting right on an earthquake fault. And as time goes by, the ground crushes and adds a whole bunch of pressure and basically turns it into this harder, kind of squished, strained rock. And you get these cool, unique stripes in them called foliation. Those are patterns of layers of all these minerals just crunched in there and squished. We have a lot of these rocks, these types of rocks in California because we have a lot of earthquake fault lines. You can find a lot of this stuff here. Here's another one. This is a metamorphic rock from most likely a limestone, which is sedimentary rock. And again, it was crushed, re-cemented, or it almost turned back into liquid, but not. It turns into almost like a Play-Doh, and then solidifies again, turns back into a solid, and now it's a new rock, as in metamorphic. So metamorphic means to change forms, and that's what these rocks have done. They've changed from either a sedimentary rock or an igneous rock, or in some cases another metamorphic rock, back into something new. One cool thing about a lot of metamorphic rocks as they tend to generate a lot of our gems that we see in our lives. Emeralds, topazes, sapphires, rubies are all from metamorphic rocks. Here's one gem in particular. It's called a garnet, and this is a pretty sizable garnet. And they all kind of have this shape. They have 12-sided crystal structure, almost like a 12-sided die. But this is a naturally occurring thing, and this is a garnet. And you would find them in these metamorphic rocks. So those are our three major types. These are obviously from my personal collection, and I obviously know what they are and where they came from. These, on the other hand, are from my house in the backyard. A lot of people have different backyards and different landscaping and rocks and things like that. I thought I'd bring some in so we could talk about how to identify them and what they might be. So starting with this one feels almost like a sand, and you can see little layers in it. This is a good key indicator. If it feels kind of sandy, it's most likely a sedimentary rock, and it's most likely a sandstone. So we would put that in this category. This one is next. Again, I just picked these up out in the backyard. This one is kind of spotty. You can see all the different spots. These are actually not grains though. If you look close enough, you can actually see little crystals in them. Because they have little crystals in them, I know that this is an igneous rock, because igneous rocks come from growing crystals only. So if it's kind of shiny and you see crystals, always going to be an igneous rock. This one is like your standard boring pebble, but it has a lot of history to it, I imagine. I'm just looking at it. Again, it feels sandy compared to this one, very similar to this. So I would classify this as probably a piece of sandstone that has had a rough journey down a river. It was rounded out and turned into a nice little pebble. But it's pretty consistent. There's not much markings on it, so I'd still put it in sedimentary. This one, just picked it up. This has had a lot of erosion on it. You can see it's kind of beaten up, little holes and stuff. But it has layers, like these black and white layers. These black and white layers are super common for metamorphic rocks. And this rock is called a gneiss with a G. And I would put it in the metamorphic category. So, I encourage everyone to go take a look out in your backyard and see if you can pick up some cool rocks and do your best to identify them, at least into sedimentary, igneous, or metamorphic. Other than that, thank you for watching. Hope everyone had a great day. Take care.